Have you ever looked up at the night sky and wondered what it would be like to jump from the edge of space? To free fall through the cosmos, hurtling towards our big blue planet? It sounds like something out of a sci-fi movie, but what would really happen if you took that leap? Let's dive into the science of an epic jump from space. First, let's define space. For the sake of our jump, let's imagine we're at the Kármán line, about 100 kilometers or 62 miles above Earth. This is the internationally recognized boundary where aerospace officially begins. Above this line, the air is incredibly thin, almost a vacuum. The first thing you'd need is an incredibly advanced spacesuit. We're not talking about your everyday skydiving gear. This suit would need to be fully pressurized, protecting you from the near vacuum of space where your blood would literally boil at body temperature due to the lack of atmospheric pressure. It would also need to regulate your temperature, shield you from radiation, and provide you with oxygen. Without it, you wouldn't survive more than a few seconds. Okay, suit on, ready to jump. The moment you step off, you wouldn't feel the immediate rush of wind like a normal skydive. Why? Because there's virtually no air resistance up there. You'd be falling, but in a very surreal way, accelerating constantly due to Earth's gravity, but without the sensation of air rushing past you until you hit denser atmosphere. This brings us to a crucial point: speed. In a true vacuum, you just keep accelerating until you hit the atmosphere. However, even at 100 kilometers, there are some gas molecules. As you descend, the air gets thicker and air resistance starts to build up. This is where things get interesting. You'd accelerate incredibly fast, much faster than a typical skydiver. Depending on your body position and the density of the air, you could potentially reach speeds exceeding the speed of sound. That's Mach 1. Felix Baumgartner, during his record-breaking jump from 39 kilometers, or 24 miles, reached over 1,357 kilometers per hour, or 843.6 miles per hour, or Mach 1.25. From 100 kilometers, you'd have even more time to accelerate before the thicker atmosphere really started to slow you down. As you plunge deeper into the atmosphere, two major forces come into play: air resistance and friction. The air resistance would eventually counteract the pull of gravity, causing you to reach terminal velocity. But before that, the friction from the rapidly thickening air against your suit would cause a significant increase in temperature. Your suit's thermal protection would be vital here, preventing you from overheating or even burning up, much like a tiny re-entering spacecraft. Now for the landing. Your parachute would be deployed much lower than a typical skydive, perhaps around 2,500 to 3,000 meters, or 8,000 to 10,000 feet, where the air is dense enough for it to be effective. The G-forces you'd experience during the initial atmospheric entry, and then again when deploying the parachute, would be intense. Proper training and a robust parachute system would be absolutely critical to survive the deceleration. So, while it's an extreme scenario, the science tells us that with the right technology and training, a jump from the edge of space is physically possible. It's a testament to human ingenuity and our endless curiosity about the world and the universe above us. What do you think? Would you ever dare to take such a leap? Let us know in the comments below. If you enjoyed this cosmic thought experiment, make sure to like, share, and subscribe for more mind-bending science videos.